Hello and welcome to another episode of Concepts 1.0. Today we are going to study about base quantities. This is almost the end of your chapter number 1, which is measurements. So we left off some certain topics which are too basic. So that's why we decided to cover up in the end. And now today we are going to discuss about base quantities, derived quantities, and the SI system, which gives us some units for measurements. So our main concern today is base quantities. What are base quantities and how they are playing an important role in physics? Important role in learning, which is you can say the fundamental of physics. So base quantities, which is very obvious from the name base, it means those quantities which are independent. Though it's not an appropriate definition to define base quantities, but this is the best way I can elaborate the base quantity to you. Independent means whenever we talk about independence, it means you are not depending upon anything. You are doing your own things. So if you need to elaborate yourself and you found a word independent, it means you can do anything by your own self. So now, if you relate this whole scenario to a quantity, which we are using in physics, for example, if I elaborate you mass. So if we are elaborating that mass is independent, what does that statement mean, like mass is independent? So we have taken the example of mass, any object's mass. For example, this is box, and we said its mass is around 70 kilograms. So this mass is independent. It doesn't need any other quantity to explain itself. Mass is what? Mass is the whole amount of matter present inside any body, whether it's a box, whether it's a human body, whether it's any wooden block, any metallic box, whatever the thing is. So, mass is what? Mass is a matter itself. It doesn't need time to explain itself, it doesn't need any force to explain mass. So, those quantities which are independent, which doesn't need the help of any other quantity, or you can say the correspondence of any other quantity for explanation of its presence. That is what the base quantities are. So in total, in general, we have 7 base quantities in physics. How many of them? 7 base quantities which are considered to be as independent or present naturally. We are going to name them one by one. First, I have given you the example of mass. So mass is a base quantity. Second, length, which is also a base quantity. Obvious is very obvious. Like length doesn't need any other quantity for explaining itself, like in centimeters, in meters. So we'll come to centimeters and meters. These are some units for base quantities, and we'll discuss those units later on. But for now, base quantities are those which are independent, which doesn't need any other quantity for its explanation. That is what your base quantity is. It's very clear from its name, like base, which means a fundamental quantity. Coming to a third quantity is time. These are some quantities which you are going to encounter in physics over and over again in a couple of chapters coming ahead. Now, fourth one is temperature. And these are some of the quantities which we are dealing in our daily life as well. Like we discuss mass whenever we go to a grocery shop. We buy something which is potatoes, tomatoes, or whatever anything you buy from grocery shop. They weigh that object particularly. So they are giving you the exact amount of mass of that particular potatoes or tomatoes you are buying. So that is mass. Length. Then whenever you go to buy some wooden sheets for making or building up a cat house or dog house, so for that particular thing, you need a length of that particular sheet, a cardboard sheet or a wooden sheet. So length is also being used in your daily life. Time. Whenever you watch a time, that's 11 o'clock, 12 o'clock. a time between your lap time for running and tracking on a running track. For exercising, you notice time. So these are some of the time examples. Temperature, you're measuring temperature. Your stopwatch, your smartwatch, these are also telling you temperatures. A temperature indication has been mentioned on your mobile phone as well. So temperature, mass, time, length, these are some things which we are generally using in our daily life. That's why we call them base quantities, because they are too fundamental. Coming to your fifth quantity, which is current. Sixth quantity is amount of a substance. And seventh one is intensity of light. These are some things, the last three quantities which I mentioned in front of you, these are some quantities which we are using in some specific scenarios. They are too specific, like intensity of light. We usually cannot mention intensity of light in normal routine. Likewise, if you wake up in the morning, so you don't mention like today the intensity of light is too much. But still, intensity of light is a too basic quantity. Why? Because sun rise up on daily basis. So its intensity goes from dim to the highest point, and then from highest point to a lowest point again throughout the day. Why? Because the movement of sun, because of the movement of earth as well. So intensity of light has to do with us in daily routine, but we don't notice that thing. So intensity of light. These are some of the seven quantities which I mentioned in front of you. Okay, so these are known as base quantities. How to elaborate a base quantity? The base quantity is basically, you can say, is incomplete without its units. Okay, so if we are not mentioning the units, we cannot particularly define any base quantity. So for defining a base quantity, there is a system which has been devised by physicians around the world, which is known as system international of units. And why we devise a unit, or a system for the whole units? Not to have a confusion around the world, because whenever anyone or any physician who's doing research on a particular subject, if he measures any length in centimeters in his country, and another physician is measuring a length in his country in some other unit, for example in yards or in inches, so when they compare these two studies, so there might be a difference in their studies. Why? Because he's using centimeters, the other one is using inches or yards. So that might create a confusion whenever they are collaborating their own studies together. So, for removing such confusions between different scientists or throughout the studies around the world, a system international has been created for removing all those confusions. So all those base quantities, they are being used around the world and using the same terms or same units. So those units which we are using for base quantities, they are known as base units. What we call them? We call them base units. Okay. And now we're going to look into base units one by one for respective base quantities. But before going into detail for looking the base units, I mentioned you like what is a unit. Unit is basically, you can say, a factor which is used to measure or which is used to describe the amount of that particular quantity. Like if I describe a length of anything, for example, the box which has been mentioned in front of you, if I want to describe a length of its one side, like its length is 7. So what does this 7 describing you? So for describing this exact or accurate amount of length, we need to have a certain factor. What is 7? 7 is in centimeters, in meters, the amount of its hugeness or tininess, you can say. How big or how small any object can be, it is being measured or can be assumed with the help of your unit. So unit is necessary with any quantity. So if you're mentioning a mass, if you're saying a number which is 1, so what is 1? 1 gram, 1 kilogram, 1 ton. So these are some units which can describe the hugeness or tininess of any object. Okay. So of any particular quantity you are mentioning. Okay. If you are mentioning the mass of any object, So by describing a number, you cannot mention like this object can be a tiny one or a huge one. Why? Because you're not mentioning the exact factor, or you're not mentioning the exact unit with it. So if you're mentioning just the number, still that number is going to be a vague, as we discussed in describing those quantities in the beginning. Like whenever we are mentioning any measurements, we are taking any measurements. So number is not enough. So you have to describe a number in particular way. Okay, you have to describe a measurement in particular way. Like when we are discussing measurements, we said like any person is tall or high. You cannot exactly tell the measurements for that person, like how tall or how small that person would be. So for that thing, measurements has been introduced. So now, in more precise and accurate way, those measurements have been given some units to describe their accuracy, to describe their precision. So for precision, units has been derived. Okay, this is why we are using units, or what is the importance of a unit. Now coming back to our topic, which is base quantities have given some base units, and we are going to look into those units one by one. Mass mass has been given a unit which is known as kilograms, and those units which are base units has been divided by system international of units, which is known as SI units. Okay, that SI means system international. That is an organization which basically decides the units to be used internationally. Now, coming towards length has been using a unit which is meters, and its symbol is, the symbol for kilogram is kg, the symbol for meters is m. For time, we use seconds, and symbol for time is small s, seconds. Temperature, we are using Kelvin, and its unit is K. For current, amperes, and its unit is A. For amount of substance, we are using mole, and its units are mol. Symbol is mol. Intensity of light is being used candela, and we are using CED for describing its intensity. So these are some of the base units. Okay, and those base units are describing a specific quantity, specific uh, base quantity to an extent. Now, after base quantities, another term which we are using in physics is known as derived quantities. Derived quantities. After studying base quantities, it is very easy to describe the derived quantities. Why? Because it is all the definitions and all the explanations has been described in their names. Mostly in physics, it happens like whenever we describe some quantity, all its detail and all its function has been elaborated in its name. As in this example, derived means those quantities which have been extracted out of base quantities. Okay, that is known as a derived quantity. A quantity which has been derived from base quantities is known as your derived quantity, or a quantity which has been extracted or made from another quantity. And in case of derived quantities, we are always making derived quantities from base quantities. So a derived quantity is a combination of more than one, or even you can say one derived and another base quantity. Okay, a combination of two base quantities or two derived quantities itself is known as your derived quantity. For example, the best example of your derived quantity is force. Force is one of the famous derived quantities. You're using force in physics 80% of the time. And what is force? Force, according to the Newton's second law, we described it as mass into acceleration. So if you look into the definition of a force or the equation of the force, mass being a base quantity. So I'm representing base quantity with the help of a BQ. Don't get confused. What this BQ stand for is just standing for base quantity. Acceleration itself is a derived quantity, so I'm mentioning it with the help of a dq. Okay, how acceleration is a derived quantity? Because acceleration itself comes from other derived and base quantities, which is when we open or simplify acceleration, it gives you delta v upon t. Okay, where t is a base quantity itself because it is mentioning time, and velocity itself is a derived quantity. So you can see one derived quantity is a combination of base and derived quantity, and another derived and base quantity. So in general, you can say derived quantities are those quantities which are being made or which are a combination of base quantities or derived quantities itself. So that is what derived quantities are. So they units which are explaining those quantities. For example, which I have given you example of force. So unit for force is what? Is very famous and has been named after a scientist who invented basically, or you can say the innovator of force is Newton. Unit of derived quantity. So unit of derived quantity is known as what? Is known as derived units. Derived units. And in case of force, it is Newton. The unit has been given a name as Newton. So all those units which are explaining derived quantities are known as your derived units. Though we cannot say like we are, it is not even necessary to mention all the time like, yeah, I am describing a derived unit. It's just for your information purposes. Like you must know like what is Newton and what's its fundamental, what is its origination. So for getting to know about any quantity or any unit, you must know its origination. Because in sometimes and some cases you have to mention derived quantities in terms of base quantities. For example, if someone says like mention Newton in terms of base quantities. So how would you elaborate Newton in terms of base quantities? It's just you have to mention Newton is equals to force. Here you force is what? Force is equals to ma. Now write down the units for m. So as m has been explained in terms of kilograms, we know mass has been mentioned in terms of kilograms. So mass we know like it's kilograms. Now going towards a, there is no such unit for a because a is itself a derived quantity. That's why we have to find out a's formula. So a formula is velocity over time. Okay, but we don't know what's the unit of velocity. That's why we have to open it up much more. What is velocity? Velocity is displacement over time. That is displacement change over time. Now displacement is what? Displacement is length. Okay. So whenever you put this velocity formula instead of this v in acceleration formula, so acceleration formula on the whole becomes delta d over t times t. That is the whole acceleration formula now. So now when we convert this formula in terms of units, we get the unit for acceleration here. Okay. So what is the unit for distance? Distance, as you know, like distance is a length of any journey. So length has been always measured in meters. So we mentioned meters over there. And time, we know like it's seconds times seconds. So whenever we have 2 seconds, it becomes meter over second square. So acceleration unit is what? Acceleration unit has been given as meter per second square. So this is our force being described in terms of base units. So whenever someone says like please describe Newton in terms of base units, so we say like yes, 1 Newton is going to be equals to 1 kilogram meters per second square. This is how we describe our derived quantities in terms of base quantities. This is our base and derived quantities on the whole in general. There is nothing much to elaborate because this topic is quite basic, and to help elaborate this topic much more, we had another thing which we have to mention here, which is known as multiples and submultiples of them. Multiples and submultiples. Why these multiples and submultiples are necessary? Because sometimes we mention them. Yeah, prefixes has to be used alongside your units. What are prefixes? Prefixes are basically used for defining the hugeness or smallness of any quantity we are describing. For example, I mentioned uh, the weight of any object, or you can say the mass of any object. So if I'm saying like, yeah, the mass is 1 kilogram, it means, yeah, it is okay. It's not too much big. But if I say the mass is going to be 1 megagram, so yeah, this quantity is going to be a huge quantity. So for elaborating those things, we are using multiples and submultiples, because whenever the quantity gets too big, so that quantity must be addressed in a proper way. So for addressing those properties in a proper way, the quantities, or you can say the numbers, has been divided in multiple and submultiple categories. Whenever the quantity is going to be get huge, we are using multiples of 10, which is means 10 raised to power 3, 10 raised to power 6, 10 raised to power 9, and 10 raised to power 12. This is the hugeness factor. Like if the quantity is going to be a huge with this certain factor amount, like 10 raised to power 3, 10 raised to power 6, 10 raised to power 9, and 10 raised to power 12. So 10 raised to power 3 has a prefix which is known as kilo. You can use kilo with any particular quantity: kilometer, kilogram, kilosecond. Basically, we're not using kilosecond too often, but yeah, if time has been introduced much more, so there are different other factors to elaborate a bigger time. But we are mostly using kilo with grams, kilo uh, with your length, kilometers. So this is the hugeness of any quantity. If your time is big, so there is no need to write down the whole number. For example, if you're mentioning like, yes, we had 1,000 grams, so instead of writing 1,000, we use a prefix which elaborates your term, means which is equals to kilo. So you say, yeah, it's kilograms. So instead of writing 1,000 grams, you write 1 kilogram, which is more precise and more accurate. So that's why we are using prefixes. So here prefix is equals to 1,000. Prefix for 10 raised to the power 6 is mega. I'm writing down its amount and then its symbol as well. So its symbol is K. Its amount is sixes, okay, and its symbol is M. Similarly, you are going to have 9 zeros here, and its prefix is giga. So you have heard about the storages of your phone, that is gigabytes, okay, 500 gigabytes, 100 uh, speed of your phone as well, like the RAM speed, okay, 4 GB, 8 GB. These are some certain speeds, because GB is been given as like you have 9 zeros. So you consider this amount is too huge. So if on someone says like, yeah, this is the amount you have to mention before any bytes, so you can say like, yeah, it's going to be much more in terms of bytes. So instead of elaborating the whole quantity, you can mention it with the help of a symbol, which is like only G. That is a prefix. So prefixes are very useful in mentioning the exact amount of quantity, whether it's a huge quantity or it's a small quantity. Similarly, 10 raised by 12 is giving you a name which is known as Terra. So it's has been gone with 12 zeros, and its symbol is only T. These are some of the examples of multiples. Multiples means whenever you're going towards a huge quantity. Now there would be another example for submultiples. Submultiples are those quantities which we describe whenever we are going towards a smaller one. So 10 raised to the power minus 3, 10 raised to the power minus 6, 10 raised to the power minus 9, minus 12. Okay, I'm elaborating some of the examples for submultiples as well. So for elaborating such quantities, whenever we're going towards a smaller one, so here we go. 10 is power 3, often described as milli. Its symbol is m, smaller one m. It's going to be a thousandth part of your 1. 1 over 1000 is going to be described as a smaller m, a millisecond, millimeter. So these are some examples for your submultiples. Similarly, going for 10 raised to a minus 6, which is describing micro, it's going to be too small. That's why we're describing it as micro. Its symbol is a U with a smaller leg at the other end. So it is describing 1 over a million parts. Okay. Then 10 raised to the power minus 9 is describing as a nano. As you guys have heard about nanotechnology, which is quite small, even that much small, like sometimes we cannot even see those things with the help of a naked eye. We had to magnify those things for seeing them. The best example of your nanotechnology is your mobile phone, is your smartwatches. These are the things. The technology has minified your electronic components that much, like they can be compact and found on your wristwatches. Like consider having the nanotechnology in a huge amount. Like if you magnify your watch, it is just a normal mobile phone. Okay. So nanotechnology has given us an advantage of minifying your mobile phone and making it as a wristwatch. So you can call and receive calls and text messages on your wristwatches as well. And this is the amount of minification you can see here in its value or in its prefixes. The symbol for nano is an N with a one leg bit longer, and its minification amount is, you can check, over 1 over this much amount of a part. Similarly, 10 is 1 minus 12 is known as pico, and its symbol is a P, and it's the same. We can check with 12 zeros. 1 divided by an amount with 12 zeros. So these are some of the examples of multiples and submultiples. Like whenever any quantity is going to be a bigger one and the other one is a smaller one. So how to elaborate, how to mention, and how to explain those quantities with the help of prefixes we are using in our units. So this is your chapter number 1, which is almost done. Let me summarize it for you. So the summary of your chapter, I'll elaborate here, writing down the summary for you from the beginning till the end. So summary explains. So in this chapter, what we have learned so far is number 1, measurements. What are measurements? As we described, like a measurement is a relation between a physical attribute and a mathematical quantity. That is what a measurement is. Secondly, finding measurement or finding volume with the help of a displacement method. Volume by displacement method. So this method is helping us whenever we don't have any exact instrument for measuring such things which are quite small sometimes, or such things which do not have a definite shape. So we are using a volume by displacement method. Okay, that is what we have learned on the second place. Thirdly, we discussed density. What is density? What is its formula? So we described about density, and it has a formula and symbol which is equals to rho is equals to mass per unit volume. Fourthly, we discussed about base quantities and derived quantities. Base and derived quantities. That is your today's lecture, which we have discussed so far. What are base and derived quantities, and how many of them base we have in total of 7 base quantities which we are using in physics, and almost the whole physics is depending upon all those base quantities. And derived quantities are what? They have been discovered or they have been made from base quantities by a combination of a base quantity, or either a combination of a derived and a base quantity. Then last but not the least, we discuss about multiples and prefixes we are using to describe base and derived units. This is your chapter number 1. Hopefully everything and every point is clear in this chapter. Still, if you guys found anything which is not clear in this chapter regarding measurements, volume and displacement method, and any other thing in chapter 1 of your IGCSE course 0625, please respond me on my Instagram. I'll elaborate and give my link in the video description. And this is from my side. See you in another video. Have a nice day. Bye bye.